So last class period, we talked about graphing y equal x minus 8 squared, something like that. Now, up until that point, we were graphing linear and quadratic functions. Is this a linear function or a quadratic function? It's quadratic. Uh, one of the things you learned last semester is squaring a binomial. So if I were to square this, at some point I would have x raised to the second power. I'd have an x squared. So the fact that y is raised to the first, y to the first, and x would be eventually raised to the second, that makes it quadratic. So the shape, remember, is a parabola. When we did this, though, at some point we started talking about translations, whether it's a vertical translation or horizontal translation. And then once we determined that, then we looked at the vertex, and we went from there. So, question becomes this. Is this right here, if I take the parent function, what is the parent function? Parent function, remember what that is? Y equals x squared. That's the parent function. So if I take that parent function, and I want to graph what you see here. So here's the graph paper. The parent function is y equals x squared. Where's the vertex of this parent function understood to be? At the origin. Okay? So it kind of makes sense because when x is 0, y is 0. When x is 1, 1 squared is still 1 and all that. So that's your parent function. So if I want to graph this right here, then you have to ask yourself, am I going to move this parent function up, down, right, or left?
Right.
Very good. It's to the right 8 units. It's not vertical shift, because if it was a vertical shift, the 8 would have to be located where?
Outside.
On the outside. The 8's inside the parentheses. And when it's inside, then it's a horizontal shift, and you got to think counterintuitive for that. You're going to understand later on in another course in college algebra why, even though you see a negative 8, why do you really go to the right instead of to the left? All right. But when it's a horizontal shift, so there's going to be a horizontal translation. You're going to go 8 units, but then you got to determine which way, right or left. Well, counterintuitive, you see a negative 8, you think the opposite, positive 8. So then in your mind, you have this. You have in your mind the origin, this graph where the vertex is at the origin. Every point on the graph is now going to be shifted which way? To the right, 8 units. So where's the vertex located now? Not 0, 8. 0, 8's here. 8, 0. Okay? 8, 0. So the vertex is 8, 0. Just like this. So once you found the vertex, remember what we did next was then we found 2 points to the right, 2 points to the left. That's all we did. 2 points to the right, 2 points to the left. And we use the idea of symmetry. We use the idea of symmetry to help us. And so when I do this then, so here's the vertex, 8, 0, right? There's a vertex. So then I'm going to pick 2 points on this side, 2 points on this side. Now, it really doesn't matter which 2 points you pick on this side, but it helps if you use the idea of symmetry. It does help. And it's going to help you understand some stuff later on in college algebra when you do translations a little bit more with it. So if this, now, first of all, where you see that vertex, what's that x value right here? The x value, 8. The y value is what? 0. So this x value is 8. Give me another x value that's to the right of it. 9. All right, if x is 9, do the t-table. If x is 9, I get this. So far I have 8, 0, right? That's my vertex. So if x is 9, I get y equals, in parentheses, 9 minus 8, and that's being squared. You'll agree that x is 9, right? You do what's inside the parentheses first. What's 9 minus 8? 1. And so I get, in parentheses, 1 squared, which is just 1. So I plot the point 9, 1. So when I plot the point 9, 1, I get this. Now, you can go and find another x value to the right at this point. What I would do at this point is use symmetry to find the one on the left. So I went to the right, and I'm going to go to the left. Now remember, use symmetry. It helps. So from this vertex, I went how many units this way? 1. And then you ask yourself, what's the y value? What's the y value? 1. So if I go 1 unit to the left, what should be the y value? 1. X is 7, your y value is 1. And now check it. Don't go further without checking, because you could have made a mistake. So check it. If x is 7, I better get 1. So let's see. Y equals 7 minus 8 squared. What's 7 minus 8? And what's negative 1 times itself? Positive 1. And that's what we said we should have had. And just pick one more value to the right of the vertex. Give me another x value on this side. 10. If x is 10, let's see what we get. I get y equal 10 minus 8 squared. What's 10 minus 8? And what's 2 squared? 4. So I get 10, 4, right? 10, 4. All right. And then I can pick any x value to the left. It could be any of these. But use symmetry. So from this vertex, I went how many units this way now? 2. What was the y value? 4. All right, so I went 2 units. My y value was 4. So go 2 units the other way. 1, 2. What's the x, though? What's the x value? 6. What's the y value supposed to be? 4. All right, and then check it. Put in the g table, check it. So if x, we said 6. If x is 6, I get y equal 6 minus 8 squared. What's 6 minus 8? And what's negative 2 times itself? 4. All right? And then just draw your parabola. Remember, the shape is a parabola. Guess something looks like this. Okay? All right, any question at this point? So notice what happened was here's a parent function. This was what kind of shift? Horizontal translation. Which way? To the right. How many units? 8. So you get this. All right? So it overlaps. Okay, now if you know the idea of translations involving quadratic functions, finding the vertex, then what we're about to do will be very similar. So it's a different function. So here we dealt with what kind of function? Quadratic. Let's look at this function. All right, so write this one down. Let's graph y equals the absolute value of x. Y equals the absolute value of x. So remember when we did the quadratic function, y equal x squared. That was my parent function, right? For the absolute value, and this is called the absolute value function. So this would be my parent function. Parent function for the absolute value function. Okay, so now we're going to look at absolute value. Now, a couple of things you got to remember about absolute value. If I ask you what is the absolute value of 2, you're going to say what? 2. If I ask you what's the absolute value of negative 5, you're going to say what? 5. So the absolute value of a number, if you look at negative 5, the absolute value of a number is the distance that number is from 0 on the number line. So this is 0, and this is negative 5. Then the absolute value of negative 5 is this distance right here. And what's that distance? Positive 5. Distance is always positive. So the distance from 2 to 0 is also 2. So the absolute value of 2 is 2. And the absolute value of 0 is just what? 0. All right, now when we graph it, we're going to go ahead and graph the parent function. So when I graph the parent function, we're going to use these values for x for the t-table. If x is 0, I get y equals the absolute value of 0. And what's the absolute value of 0? 0. So I plot the point 0, 0. Now some grid paper on that table over there if you need grid paper. So 0, 0 is the origin, right? If x is, let's say, 2, I get y equals the absolute value of 2. And what's the absolute value of 2? 2. So I plot the point 2, 2. If x is, let's say, negative 2, I get y equals the absolute value of negative 2, which is 2. So I plot the point negative 2, 2. Just like with the quadratic function, this has symmetry. The idea of symmetry as well. If x is, let's say, 4, I have y equals the absolute value of 4, which is 4. So I plot the point 4, 4. If x is negative 4, I get y equals the absolute value of negative 4, which is also what? 4. All right, and then I want you to notice this time that when we, first of all, when we dealt with the quadratic function, the graph, it was a parabola. You had that curve. Here, this is not a parabola. The shape, if you connect the points, those are rays. Looks like this. So the shape is a V, is the shape of that V. There's really no special name for this, like there is for a quadratic. We say it's a parabola. There's no name for that. You just call it shape of a V. Right? And knows that this point right here is called the what? No. I mean, it's at the origin, but what's that point called? The vertex. It's called the vertex. So everything we're going to do now is going to be similar to what we did with the quadratic function, except the shape is different. It'll be a V instead. Okay? All right. Now let's look at this one. So this is your parent function. This is y equals absolute value of x. That's the parent function. All right, suppose we want to graph this instead. Suppose we want to graph y equal the absolute value of x, subtract 3. Y equals the absolute value of x, subtract 3. All right. So remember, just like we did with quadratic functions, first thing you got to do is ask yourself, is this a horizontal translation or a vertical translation? What is it? Vertical, because the number's on the outside of the absolute value bars. All right. Now, if it was the inside, you think counterintuitive. Here, you take it, you do what you see. So basically, I have my parent function, looks like this, and I'm going ahead and use the same grid that I did with the parent function. So look, here's my parent function, right? Okay, so there's going to be the blue one right here. Here's my parent function. I want to graph this. So we know that this is what kind of translation? Horizontal, vertical? Vertical. So it's a vertical translation. Now what I mean by that is I'm going to take the parent function and I'm either going to go up or I'm going to go down. When you go up or down, it's basically what you see. So when you see subtract 3, it means you're going to do what? Go down 3. So in your mind, you have this. You have your parent function, and you're going down 3. 1, 2, 3. So instead of the vertex being at the origin, the vertex for this, in your mind, you see the origin, but instead you're going which way? Down 3. So you're going down 3 units on the y-axis. So what's the vertex going to be then? Not negative 3, 0. I mean, you said negative 3. It is negative 3 on the y-axis, but give it to me as an ordered pair. 0, negative 3. Okay, not negative 3, 0, because negative 3, 0 is on the x-axis. So there's your vertex. So then you plot that point. So there's a vertex right here. And then all you do is like we did before. You find 2 points to the right, 2 points to the left. All right? So if I look at the vertex, what is the x value right here? The x value? No, what's the x value? 0. So now give me a 2 x's to the right of it and 2 x's to the left. So let's do the right. Give me an x value to the right of 0. No. Give me give me one x value to the right of this. 2. Okay, x is 2. We use the t table. So right now I know this. I know that the origin is 0, negative 3, right? Now you know someone could have made a mistake and said negative 3, 0. You can always check yourself. Just go back and make sure this is correct. If x is 0, what's the absolute value of 0? And what's 0 subtract 3? Negative 3. Okay? All right. So I get 0, negative 3, so that's your vertex. We said x is 2, right? So if I let x be 2, I get this. I get y equals the absolute value of x, and what's x in this case? 2. Whatever that is, I'm subtracting 3. What's the absolute value of 2? And what's 2 subtract 3? Negative 1. So I plot the point 2, negative 1. 2 negative 1's right here. Okay? 2, oops, I'm sorry. I did 2 negative 1. I'm sorry, it's not right here, it's right here. Y'all agree? All right, I put it in the wrong place. Right here. This is it. 2, negative 1. Okay, so now let's use symmetry to do the other side. So from here I went how many units to the right? 2. And what was my y value? Negative 1. So I'm going to go 2 units to the left, and what's going to be my y value? Negative 1. Your x value is negative 2. All right, so you get that. So let's check. What's the x value? X value? Negative 2. Let's see if it's true. If x is negative 2, I get y equals the absolute value of negative 2 subtract 3. What's the absolute value of negative 2? And what's 2 subtract 3? Negative 1. And that's what we said it was supposed to be. Okay, give me one more x to the right of the vertex. 4. If x is 4, I get y equals the absolute value of 4 subtract 3. What's the absolute value of 4? And what's 4 minus 3? 1. So 4, 1. So I get this right here. So far I know that this part of the graph looks like this, right? So let's do the other side. Now notice from the vertex I went how many units to the right? 4. And what was my y value? 1. So I'm going to go 4 units to the left. 1, 2, 3, 4. What better be my y value? 1. So let's check it. What's my x value? Negative 4. Let's see. When x is negative 4, I get y equals the absolute value of negative 4 subtract 3. The absolute value of negative 4 is 4. 4 subtract 3 is 1. And that's what you wanted. And so there's your graph. So this right here is the graph. Y equals absolute value of x subtract 3. All right. And then if you had access to transparency like this, you have your parent function, and you know that you're shifting this down 3 units, and you get this. All right. So that is one of them. Now let's look at another one. Suppose this time you had, let's say you want to graph f of x equal the absolute value of x plus 7. Remember, f of x, that function notation, you're going to learn about function notation Tuesday. But that function notation, f of x, what does that stand for? What letter? Y. So it means the same thing as y. All right, now, is this going to involve a horizontal shift or a vertical? It's a vertical translation. Now, what that means, again, is this. What that means is, if I look at my parent function, what's the parent function? Y equals that's the value of x. So here's my parent function. So that means that I'm going to take my parent function to graph this. I'm going to move it where? Up 7. Good. So this is what kind of translation? Vertical. And then you just do what you see. So that plus 7 means that you're adding 7 to all these points. So you're moving it up 7. So in your mind, you know that that the vertex is located at the origin. So you're moving it up, right? So you're moving this vertex along the y-axis. So when I move along the y-axis, I'm getting what y-coordinate?
0, 7.
0, 7. Your y-coordinate is 7, so your points will be 0, 7. So your vertex is 0, 7. That's your vertex. So you apply that point. And then you pick 2 points to the right, 2 points to the left. So give me another x value that's to the right. 2, all right, if you let x be 2. So far we have this. We have 0, 7, which is the vertex. Now if x is 2, I get y equals the absolute value of 2 plus 7. What's the absolute value of 2? And 2 plus 7 is 9. So 2, 9. So I plot the point, 2, 9. Now remember, this absolute value, so the shape you want to do that v. So all those points better lie in the same ray. Well, let's use symmetry for this one. So from the vertex, I went how many units to the right? 2. And what was the y value? What was the y value? 9. So I'm going to go 2 units to the left, and my y value better be what? 9. So when I go 2 to the left, what's that x value, though? What is it? Negative. I put it in the wrong place again, huh? All right, so it's right here. Right here. So negative 2. So if x is negative 2, if x is negative 2, we get this. You get y equals the absolute value of negative 2 plus 7. What's the absolute value of negative 2? And what's 2 plus 7? 9. All right, give me another x value to the right of the origin. To the right of the vertex, excuse me. 4. So if x is 4, I get y equals the absolute value of 4 plus 7. What's the absolute value of 4? And 4 plus 7 is 11. So I plot the point 4, 11, which is here. And so now I know this part of the graph looks like this. So remember, that's 4, 11. Let's use symmetry. So from this vertex, I went how many units to the right? No. 4, right? What was my y value? 11. So I'm going to go from this vertex, instead of going 4 to the right, I'm going to go which way? 4 to the left. 1, 2, 3, 4. And my y value still better be what? 11. Now let's check. What's the x value? Negative 4. So when x is negative 4, I get y equals the absolute value of negative 4. And then plus 7. The absolute value of negative 4 is 4. 4 plus 7 is 11. Okay? All right. And so you just draw your rays, and there's your graph. So again, in terms of the parent function, basically what you did to graph this function was, here's the parent function. I'm going to take the parent function, I'm going to shift it up 7 units. And you get this. All right. Okay, now let's look at this one. All right, suppose you had this. Suppose you had y equal, you want to graph, y equal the absolute value of x minus 6, like this. That's the value of x minus 6. So it's very similar to quadratics, except the shape is different. Is this a horizontal or vertical translation?
Horizontal.
It's horizontal because the numbers on the inside of the absolute value bars. So you know it's horizontal translation. And basically what's going to happen is that if this is your parent function right here, to get this one, I know it's horizontal, and I see a 6. So either move it to the right 6 or to the left 6. Which way? To the right 6. Because you think counterintuitive, right? So if your vertex at the origin and you move it 6 units to the right, that becomes 6, 0. 6, 0. So your vertex is 6, 0. Not 0, 6, because 0, 6 is on the positive y-axis. So remember, you're moving it to the right. Okay, so 6, 0 is here. And all I do is just find 2 points to the right, 2 points to the left. So give me another x value that's to the right of the vertex. 8. So if x is 8, I get y equals the absolute value of 8 minus 6. What's 8 minus 6? And what's the absolute value of 2? 2. So I plot the point 8, 2. So 8, 2 is right here. Now use symmetry to find the other one. It helps if you think of symmetry. So from the vertex, I went how many units to the right? 2. What was my y value? 2. So now I'm going to go 2 units to the left. So I'm going 1, 2. So I'm at x equal 4. And what's going to be my y value? No. 2. Y value is 2. So let's check it. When x is, what's x here? 4. When x is 4, I better get my y value to be what? 2. So I get y equals the absolute value of 4 minus 6. What's 4 minus 6? And what's the absolute value of a negative 2? 2. So you get 4, 2. Okay? Okay, one more value to the right of the vertex. What'd you say? 10. All right, if x is 10, I get y equals the absolute value of 10 minus 6. What's 10 minus 6? And what's the absolute value of 4? 4. So I plot the point 10, 4, and I get this. Right? And so I know this part of the graph looks like this. You just draw your ray, looks like that. Now remember, don't draw a line with 2 arrows right here. Remember, it doesn't do that, right? This is your vertex. This is where that point ends. All right, let's use symmetry. From the vertex, I went how many units to the right? 4. And what was my y value? 4. So I'm going to go 4 units to the left. 1, 2, 3, 4. And what's my y value? 4. All right, let's check it though. What's my x supposed to be? 2. When x is 2, let's see what we get. When x is 2, I get y equals the absolute value of 2 minus 6. What's 2 minus 6? Not 4. Negative 4. What's the absolute value of negative 4? 4. So you get 4. And then you plot you plot the points, and then you graph your array. And so there's your v. So this is the graph y equals the absolute value of x minus 6. All right, let's do one more. And it's going to be this one. So let's suppose we had y equals the absolute value of x plus 5. All right, where's the 5 located? Outside or inside the absolute value? Inside. So is that a horizontal or vertical? Horizontal. So you think counterintuitive. Okay, so horizontal translation. So if I look at the parent function, here's the parent function, right here, where the vertex at the origin. And remember we said horizontal, so am I going to move it 5 units to the right or 5 units to the left? Yeah, because you think the opposite of this. So positive 5, you would think to the right 5, it's actually the opposite. You'll learn reasons in another course. So it'll be 5 units which way? To the left. All right. So when I go to the left, remember you have the origin. So when I go to the left 5 units, what's the vertex now going to be? Not 5, 0. Not 0, 5 either. Negative 5, 0. Negative 5, 0. And it's not difficult. I mean, you think about it in your mind, but when you have graph paper, it's easy to do because look, in your mind you're saying, well, this is where my vertex was for the parent function. I've got to go which way? To the left 5. So this is it. So what are the coordinates? Negative 5, 0. So that's your vertex. Negative 5, 0. And then all you do now is just find 2 points to the right and then 2 points to the left, and you draw your v. You draw your absolute value function. So give me an x value to the right. Negative 3. All right. So if x is negative 3, let's see what we get. So I get y equals the absolute value of negative 3 plus 5. What's the absolute value? I'm sorry. What's negative 3 plus 5? Negative 3 plus 5. 2. And what's the absolute value of 2? 2. So I'm going to plot the point negative 3, 2. So negative 3, 2 is here. Now let's use symmetry to find the other side. So from the vertex, I went how many units to the right? 2. And what was the y value? 2. The y value was positive 2. So now I'm going to go 2 units to the left, and my y value better be what? 2. Okay, let's check it. What's my x value? Negative 7. So I get y equals the absolute value of negative 7 plus 5. What's negative 7 plus 5? Not 2. What's negative 7 plus 5? Negative 2. And what's the absolute value of negative 2? 2. All right. I need one more. Give me another value to the right of the vertex. Negative 1. So if x is negative 1, I get y equals the absolute value of negative 1 plus 5. What's negative 1 plus 5? Huh? 4. And what's the absolute value of 4? 4. So I'm going to plot the point negative 1, 4. When I plot the point negative 1, 4, I get this right here. And now I know what this part of the graph looks like. It looks like this. And so let's use symmetry to find the other one. So to get to this point, I went how many units to the right? 4. What was my y value? 4. So I'm going to go 4 units to the left. 1, 2, 3, 4. And what's going to be my y value? Positive 4. So let's check it though. This is negative 9. So when x is negative 9, I better get 4. Y equals, that's the value of negative 9 plus 5. What's negative 9 plus 5? Not 4. Negative 4. And what's the value of 4? 4. And you get 4. And so there's your graph. So this is the function y equals absolute value of x plus 4. Okay, and it makes sense because if you do look at the parent function, oh, plus 5, yes, thank you. All right, so if you look at the parent function, to graph this, I've got to take the parent function, move it 5 units to the left, and so you get this. They should overlap. Okay. Okay, so that was the end of that part.